357 is a blank page, and we are going to add 2 more graphs. Now, these graphs are, in a lot of ways, identical to the questions that we just did. So we just did transformations with an exponential graph. I'm just going to introduce you to a new base, to a new number that maybe you've never even seen before. How many people have seen this number? E. The number E. Not to be confused with the letter E, even though they look very similar. The number E. Have you seen the number E before? It's on your calculator. See if you can find the number E on your calculator. No, not the double E, just the number E. See if you can find the number E. So when you type it in and push enter, it should tell you what the number E is equal to. Unless you know what the number E is equal to. Yes? No? Oh, we've got E here. You can put an exponent with it. An exponent of 1, because if you wanted just E, you'd have e to the 1. 2.718281828, and it continues. Even though it looks like it's going to continue with that pattern of 1828, it doesn't. It's one of those numbers like pi that goes on forever and has no apparent pattern in the numbers. Even though it does, it's much easier to memorize the first 10 digits of E than it is to memorize the first 10 digits of pi because of that 1828 repeating itself. Okay, so that's the number E, and now we can graph it. What does the graph of y equals e to the x look like? Well, it's an exponential, so it's going to have this point. That's the same as every exponential. 0, 1. And it's going to have this point, 1, that number. So you can just write 1, e. And it goes like this with an asymptote at y equals 0. What makes that a special number? We'll talk about that in a bit. We'll do one more example, and then we can talk about why E is special. Just like why pi is special. So now that you know the parent graph, you could graph any graph with transformations. So we could have 3e to the x minus 2 minus 1. And go about it the same way that we did with our other graphs. Now, the only difference, though, is that we have a weird number to start with, E. So just because it's different, it makes it a little bit trickier, but the idea is exactly the same. We go from left to right. When we go through our stretches and compressions first, what are we going to multiply y by? Y by 3. X by? Don't have to do it because there's a 1 there, right? So just have to do y by 3. So then you would get 0, 3. That's easy, but then what do we do here? 1, 3e. 3! Yeah. Excellent. And then we get the minus 2, which will be 2 to the right, and the 1, negative 1, which will be 1 down. So this one is easy. It's going to be 2, 2. And this one, moving 2 to the right, is going to be 3, 3 minus 1. Yes, perfect. Oh, and we should also write our asymptote here. Does anything affect our asymptote? So it's going to be at y equals negative 1. So when we go to start our graph, that would be the first thing I would put in. Y equals -1. I would plot the points that I have. 2, 2 is easy to plot. 3, 3e minus 1. Now, e is 2.7, which is not super close to 3, but kind of close to 3. So if you do 3 times 3 is sort of an estimate, you get 9. 3 times 2.7 would be 8.1. 8.1 minus 1 will get us to be at 7.1-ish, so I'm going to estimate that to be there and just label it as an exact value. If you had your calculator, you could approximate that to 7.18. No, 7.1 something or 7.2 something. 1.5. Okay. And now that we've got those 2 points, as far as which direction does it have to go, it looks like this. I drew mine right through the origin. It doesn't go right through the origin, but we're not labeling the y-intercept at this point. This would be all we would need to do to graph this. So that's the number e.